Hello all you rocket fans out there, this is just a brief update from the Copenhagen Suborbitals workshop. As you might know, we didn't get to launch the Nexø I rocket this year due to partly technical issues and also the weather in our launch area. But I'm actually standing right here in the workshop now beside the almost finished Nexø I rocket. As you can see, we have assembled everything. Right now there are a few parts that have been taken out for testing. But the only thing missing right now is actually just the LOX cleaning, and then the Nexø I rocket is ready to go. And the plan right now is to launch it at the first possible opportunity this spring, once the weather is good enough and the sea temperatures in the Baltic Sea is okay for launch. And if you look just over there, you can actually see that we have begun the production of the Nexø II rocket. And the plan right now is that both the Nexø I and the Nexø II will be completed this winter, so that we can launch both rockets in the early spring. The Nexø II rocket will differ from the Nexø I in a way that it will have a dynamic pressure regulation system. A technique that we really need to test and finalize before we can use it on the Speaker rocket. So this is going to be a very exciting spring with the two launches of Nexø. But that's not all, because of course we are already on track of developing the Speaker class rocket. And this winter we will commence with the testing of the injectors and hopefully also the first prototype of the Speaker engine. So it will be a very busy winter in Copenhagen Suborbitals. The next little video clip that you will see is recorded just before the planned launch of this year, and you can see some very nice images of the cold flow test we did on the rocket, and you will also see some experiments that we did with the insulation system for the liquid oxygen tank.
Frem, når vi begynder at løfte op.
Så er det i gang. Skønt. Jeg synes. Så tager vi et kvartal. Ja, det er like that angle. Higher. Okay, good. Skal jeg løfte den der? Ja. Hvor længe holder du klokken?
Så ned igen. Så er den der til siden. So today we are conducting the final flow tests on the flow calibration tests on the Nexø I flight system, and the point of these tests are to establish the calibration values for pressurization system and for pressure losses in particular throughout the system. In fact, this is divided into three separate tests. So the first test today will in fact be what's called a cold soak test. And here we load the liquid oxygen tank with the liquid nitrogen, which is simpler to handle as it's a more inert medium, and we allow the rocket to sit on the rail with the tank nearly completely full with liquid nitrogen, and then we simply sit and watch and determine what's the evaporation rate within the tank. And this is done to evaluate the quality of the insulation that we've installed on the tank, and also this gives us an idea of how long we can have the rocket sitting on the pad and how the propellant loading of the tank will evolve over time if we end up in a situation where we have to hold due to ships in the range safety area or so forth. Following that test, we'll proceed immediately to what's called the cold flow test. So in that respect, we flow the liquid nitrogen through the main valves and out through the engine. And this is done to establish the flow calibration parameters for the engine using the cryogenic media that liquid nitrogen is. And this allows us to derive the exacting parameters for a liquid oxygen propellant with the same setup. And finally, we will be conducting a series of ordinary flow tests, so to speak, where we load the entire system with demineralized water, and then flow the system with 3 different tank pressures to establish the calibration parameters for both fuel and liquid oxygen side. These tests are very similar to what was done on the test stand for the BPM-5 tests. But of course, you need to do this again in the rocket, mainly due to the fact that the piping is different. You have longer feed lines between the tanks and the engines, and you have the tanks placed on top of each other. So we also have the hydrostatic pressure component to deal with. So all in all, once these tests are completed, you have a complete picture of the flow characteristics of the flight vehicle. And that allows us to finally calculate the flight tank pressures for Nexø I and establish, sort of say, the final capabilities of the vehicle.
All the pushed out from the nav is here we have a model here of our rocket. So the rocket is basically the pipe here in the middle. And we can see the two cable channels on the left and right. And here's the launch rail. And well, we decided to use as oxidizer liquid oxygen. So we need to isolate these tanks to keep the oxygen cool. So we have here the styrofoam isolation. These are 4 pieces. They are connected. On that model it's taped, but we will use a different system on the real rocket. And well, it should work like this. The thing is, we could maybe have a problem if the rocket lifts off, that the fin could hit the styrofoam, because the styrofoam is just kind of loose there, and we want to avoid that. The styrofoam can cause any damage to the rocket. So the thinking about the whole system here is we have rubber bands which kind of make the styrofoam peeling off the rocket. So what we're going to use then, we use a kind of a wire cutter. So I just simulate that right now. So we cut the wire here, and now just watch what happens to the styrofoam. It makes that. So we try to replicate that on the real rocket. And well, that's right now what I'm working on. So these are the real pieces. So I hope that will work. We have some slots here for where the stick goes in and where all the stuff and the elastic cord gets mounted. So these cords here, they will be replaced with the cords we have down here. So I kind of try to replicate that system, and yeah, I hope that will work then, and we will test it for sure. Yeah, it was not sticking, nothing. It worked. And it looks still okay.
Yeah. Are you a happy man now?
Yeah, of course.
So now we've completed the first 2 tests of the day. That would be the cold soak and the cold flow test. And the cold soak test went as anticipated, and we now got an estimate of the evaporation rate from the cryogenic tank on the rocket. And we also got to test the insulation, in particular the fly-away insulation that covers the tank when it sits on the pad. And all those elements functioned as anticipated. The cold flow test has given us some problems of the day. In this test setup, we're running the engine controller from an external power supply, and as it turned out, the cold in the motor compartment essentially made it so that we needed an excessive amount of power to turn the main valve, so the main LOX valve. So the power supply we had hooked it up to only had a current limit that made it impossible to actually turn the valve. So now we rewired the power supply and strung 2 power supplies in parallel, and we successfully completed the cold flow section. Of course, this is a minor issue in terms of how this works in flight, because in flight we are operating the valves of batteries in the rocket. And that, of course, means that the current limits are those set by the servos actuating the valves, not by an external power supply. So in essence, this is an issue that doesn't really relate to flight. It only relates to the test setup here. But the cold flow section went as anticipated, so we should be able to extract the cryogenic calibration parameters from that test. And now we'll move on to the third test of the day, which would be the baseline flow tests using water once the vehicle has thermalized to ambient temperature. And those will then give us the parameters for sizing the operating point of the engine in the flight vehicle.